Hi, my name is Dale McKay. I'm with the Global Infrastructures Consulting Service, and I'd like to take you through a quick and speedy method for doing IP subnetting. So when we think about an IP address, we have 4 octets, and along with every IP address, we're going to be given a network mask. That network mask is used to define the boundary between the network portion and the host portion of a particular IP address. Now, traditionally, subnet masks have fallen on what we could term as natural boundaries, a /8, a /16, or a /24. The /8 would be here, /16 would be here, the /24 would be here. The slash in the number represents the number of bits that we're using for that network mask. 8 bits, 16 bits, 24 bits. And it's pretty easy to figure out where the network portion and where the host portion is on these subnet masks that fall on a natural boundary. In other words, if we just use the /24 as an example, we know that we have 24 bits of subnet masking going on, which means that this is the network portion and this is the host portion. So I have 8 bits for host addressing, 24 bits for network addressing, which means I'm going to have a lot of networks, but each of those networks will have a relatively small number of hosts on. And everybody's pretty comfortable with a /8, /16, /24 because they fall on a natural boundary. The problem arises when you have a subnet mask that doesn't fall on one of these natural boundaries. It's not easy to just look at the IP address and understand whether it's a network address, a broadcast address, or a usable host address on one of the particular networks. So just to recap a little bit on IP addressing, in every IP subnet, we're going to have the following addresses. We're going to have an address for the network. We're going to have usable host addresses. And then the last address in that particular IP subnet will be the broadcast address. Every IP subnet, regardless of its size, has those 3 addresses associated with it. An address for the network, usable addresses, and broadcast address. What I'm going to show you is an easy method that you can use to quickly determine whether a particular address is a network address, a usable address, or a broadcast address on a particular subnet. All right, so let's start with a network mask of /30. Now this is a pretty popular network mask for doing 2 connections, like a serial connection between 2 routers, because I only need a couple of addresses. I'm going to show you how you can quickly determine, once again, whether it's a network, usable, or a broadcast. We call this the magic number because it's a mathematical exercise that once you understand the concepts, you'll be able to very quickly, almost visually, look and determine whether the address is network, usable, or broadcast. So a /30 gives us a magic number of 4. Now, where's that magic number come from? If we take /30, that means we've actually moved this network boundary, and let me replace this X with 8 bit positions, which would. So actually what we've done is we've shifted the network portion over 6 places. So we've taken 6 bits of those 8 bits and we've assigned it to the network portion, which leaves us 2 bits for our host address. Now, in binary terms, how many unique numbers can I express with two binary bit positions? The answer is 4. The only valid numbers for these two positions are 00, 10, 10, and 11. Those are the only numbers that I can represent with those two bit positions. You can see that I represent 4 unique numbers. In this particular case, if we were to assign an IP address to this, this would be my network address. These two would be usables. And this would be my broadcast address. Now, we haven't actually given this an IP address. Let's do that. Let's use the address of 192.168.100.20. And it's going to be on a /30 network mask. And my question is that a network, a usable, or a broadcast? Well, using our magic number, and here's the key to the magic number. The network address will always be evenly divisible by the magic number. The network address will always be evenly divisible by the magic number. So if I know the network address, then I know the broadcast address for that particular network. Because how do I know that? It's one less than the next network address. This would be my second network address. This is my first network address. First network, second network. This would be usable in the second, broadcast in the second. Then we go back to network for the third. This would be my third network address. What I'm saying is the key to this entire conversation about magic number is that the network address will always be evenly divisible by the magic number. So in this particular case, we look, is 20 evenly divisible by 4? Yes, it is. So this is a network address. We know the next network address would be 24. So that means the broadcast for this network, the 20 network, is 23. That makes 21 and 22 usable addresses. You say, okay, I kind of get that for a /30. What about if it's a /29? Well, let's do a /29. The magic number for a /29, remember, we knew how to derive a magic number here because we had 2 bit positions. We could represent 4 numbers with 2 bit positions. Now if I move the line between the network and the host, if I move it back 1 position, so now I have 29 bits. Here's 30, 31, 32, 29 bits where the network addressing. I now have 3 bit positions. So how many unique numbers can I represent with 3 bit positions? The answer is 8. If you were to draw this out, you would see that I can represent 8 unique numbers using 3 bit positions. So that means in a /29 network, my magic number is 8. Again, if we go back to the fact that a network address will always be evenly divisible by 8 in this particular case, and we use this same IP address, 192.168.100.20, and this is on a /29, we need to determine what that address is. Is that number evenly divisible by 8? It is not. What number is evenly divisible by 8? 16 is. And then 24. So the 20 address is part of the 16 network. The 16 network will have a broadcast address of 23. Everything between 17 and 22 are usable host addresses. All right, let's do a /28. /28. The magic number is 16. So that means my network address is going to be evenly divisible by 16. We'll stay with the same IP address, 192.168.100.20 on a /28 mask now. Is 20 evenly divisible by 16? It is not. What is evenly divisible by 16? 16, and then my next network would be 32, which means the broadcast for this 16 network on a 28 mask is 31. That's the broadcast address. The network address is 16. That means from 17 to 30 are usable host addresses. All right, let's do a /27. /27, my magic number is going to be 32. We'll stick with the same IP address, 192.168.100.20 on a 27 mask. So is 20 evenly divisible by 32? It is not. Now what's been implied here, and I haven't said it, is the fact that the number 0 is a legitimate network address. That's the 0 network. That's a legitimate network address. In this particular case, the 20 address is part of the 0 network. What's the broadcast address for this? It would be 31. How do I know that? Because my next network address is going to be 32. This would be my second network. First network is 0. So, from 1 to 30 are usable addresses in the 0 network on a 27 mask. I think by now you're kind of starting to get the idea of how to use this magic number. A /26 network. My magic number is going to be 64. Now, using this IP address, we're just going to kind of wind up at the same place. It's going to be part of, let me just go ahead and draw it out. On a /26, this is going to be part of the 0 network. What's my broadcast for this network? It's going to be 63. How do I know that? Because 64 is my next network address. So anything between 1 and 62 would be usable addresses. All right, let's move on to a /25. The /25, my magic number is going to be 128. So once again, my network number will be evenly divisible by 128. In the case of 192.168.100.20, the one that we've been using, what's going to be my network address? It's going to be 0 again. What's going to be my broadcast for that network? It's going to be 127. All right, because 128 would start my next network. So the whole idea behind this magic number is just to give you a quick and easy way of identifying whether the address that you've been given or the address that you want to assign to a device, if it's in the proper subnet, and is it a network, a broadcast, or a usable address. All right, thank you very much for your attention. I hope this is helpful.